Hi, this is Lab 4 bar magnets. So for purpose and concepts, we measure how distance affects the strength of a magnetic field, and then we compare the experimental results with the Biot-Savart law. We also need to factor in the magnetic field of a dipole, and for results, we got that the magnetic dipole moment is 33.13, which is higher than the theoretical average, but we'll go into that later. So for concepts, one is the Biot-Savart law, which measures how a rod creates a magnetic field, and then we also need to factor in the magnetic field of a dipole, and then the distance dependence law, which measures the strength of a magnetic field in its relation to distance. So for a procedure, we first align with the north, so we rotate our smartphone until the magnetic field in the x direction reads 0 to cancel out the Earth's natural magnetism, and then we want to locate the sensor on the phone, so we move a magnet around the phone to find the exact spot of the sensor. And then for measuring distance, we slide the magnet to different distances along a ruler and measure how the magnetic field strength changes at each stop. So we see the relationship between distance and strength of the magnet. So for our calculations, we first exponentiate E to get the K value, which is around 6.625. Then using the Biot-Savart law, we know that K equals some constant times 2 times mu. And we know that 2 times mu is around 66.253, and dividing that by 2 gives mu a value of around 33.13. So for our off-axis simulation, the orange arrows show the magnetic field on the axis of the stick, and the cyan arrows show the magnetic fields at the sides, which will point the opposite way. And at the same distance, the orange on-axis is twice as strong as the cyan arrows. So for our observations, we see, so first, when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. This is true. As you get further away, the magnetic field in general just decreases. Number two, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field decreases. This is false, according to the formula, the Biot-Savart law. And the position of the magnetometer has no effect on the measured x component of the magnetic field. This is false because we know that the position of the field can either result in a 1 or 2 times scalar multiple. And then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. This is true. So for discussion questions, what if you hadn't oriented your experiment to compensate for magnetic north, and instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your result have changed? So if we didn't do that, then Earth's magnetic or natural magnetic field would mix with the magnetic field in the x component readings and would potentially make our readings inaccurate. And then what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? So if you stuck two identical magnets together, we effectively doubled the magnetic dipole moment because the magnetic field strength is directly proportional to mu.